Oh, I heard about that. Let's see how I get the word or something. A cheat. Just see what's okay. Like the other day, I was like, this is 2 hours. Away from one another, I haven't seen her in like before COVID for sure. Yeah. It's not even like 6 years. She came back to school. To get her notes. She has a degree in that. She's going to start teaching this year right after that. I'm looking for them to carry my conversation with Rena. There's some people that are stuff but I'll let y'all know.
I guess let's start with has everyone been able to install the compiler I linked to? Compiler setup. Oh, that's an extension that gives you IntelliSense. So that's like just to mess with the editor. That's not a compiler itself. I posted a link, and if you have a Linux VM, you can use that if you want, or you can install the what I linked to in the Discord. This link.
Like if we've done 1320, then we should everything should be fine then, right? Because that's encoding.
Whichever workflow. You mean like in using the Linux VM?
Yeah.
Yeah, that should be fine.
Okay.
Does anyone not have a compiler set up? Yes, you can use Clang. You have Clang pre-installed. Is this the right link? All right, I guess let me phrase it a different way. Does anyone not have the compiler set up? No? We're all good? Okay. Okay. Oh, here. I think this is the wrong link here. The compiler. I'll go to this link. I posted the wrong link.
Okay.
It's on the side. Yeah.
Oh, okay.
There should be an installer. All installations. I do that as well on this laptop. So I'll show you what I'll do to run it. Okay. So I download the installer. Set up installer. Directories. Take a second. I guess while that is waiting, we can start the presentation. Okay, so actually this lecture is going to, not lecture, kind of onboarding is not going to cover Raspberry Pi. That's going to be pushed over to the other session with NFC toolchain stuff. I think it just fits more into that at that point. Again, set up the compiler. This is that link that I posted in the chat. If you already have a Linux VM, that's fine. Mac doesn't need it. You can just use the Clang compiler. So whenever I put in GCC, you can just put Clang, and then it's basically one for one. Here are, does everybody have VS Code installed? Here are the extensions that on the right are the ones that are recommended, and the ones that are on the left are kind of best. You should probably have this. So I can show you how to get to that. If you open a, okay, if you go to Visual Studio, you can go up on the sidebar. You should see extensions. And you can just type /C/C++. And the first three should all be from Microsoft. So you just go to here. If you don't have it installed, you press install. Check these. You want Clang, Clang format. This will kind of reformat your document to fit a style, if that makes sense. So it'll help you keep a consistent style. You just right-click on the document and then say format, and it'll the specific way you specify. You can change it later on, but you can just leave it as the preset. And then the last would be colorizing bracket pairs, right? So if you see, if I write something here, I can just show you where it's in settings. It used to originally be an extension, but VS Code has absorbed it into the default text browser. You just have to turn it on. So if you go to settings, the text editor, right? And then you scroll down, you should have bracket pair colorization enabled. And this just turns, it assigns a color to each bracket pair. So you can easily see kind of when you get nesting involved. Okay. Yeah, this is live stream. I put the link also, I think. Yes, should be in there, yes. Okay. Another thing that's kind of important that you won't be taught in your classes are shortcuts. This is probably one of the best things, most efficient things to do with your time. Really get used to not using the mouse. It's really easy to use GUI, but it's kind of just efficiency. If your hands are always on the keyboard, you can always code. You can always do, instead of right-clicking, selecting, dragging, you can all do it in one stroke, essentially. That can make your coding experience way more fluid, and if you get more used to it. So I'll drop the link for the Windows shortcuts and the Mac shortcuts as well. If you go and see the document, you can see basic editing. I wouldn't focus on learning it all at once, kind of just looking to incorporate every time you go into coding. You can kind of like add just one, if you just learn one command, like cut line, Control X. I know everybody knows Control C, Control V. A lot of people should know that, but Control X, you can do a lot of line moving, duplicating a line, makes it really easy to do things. If you want to go to the max of this would be Vim. If you go and use Vim or Emacs, doesn't matter which one you learn, just learn one and it'll increase your productivity, essentially. Okay. All right, and then now into C. What is C? It's a programming language made in the 1970s, and it's kind of become this kind of large overarching thing that has consumed a lot of lower level code bases, if that makes sense. If you want to build something that lasts a long time, or you're working on something that is really old, it'll have C. It is between, if you were working on stuff that's really old, it'll either have C or COBOL, which is another programming language that's completely focused on like databases. So C is statically typed and procedural. So that means there's no funkiness they have to worry about. I know a lot of people probably got very confused with the JavaScript introduction, where you have imperative languages, functional programming, kind of this abstraction level. C is very low level. I'll actually link afterwards a YouTube video of kind of a comparison between C, assembly, and like physical machine code, the zeros and ones and binaries. And you'll see they're very in line with each other compared to a lot of other higher level languages where you code a couple lines, you can just easily do a sort. You just sort, pass it your list, and it'll sort it for you. C, you have to do everything yourself. And C is what powers a lot of the stuff that we use that's underlying, like operating systems. MySQL uses it. Python's interpreter uses it. So that's something to think about. And the main reason we want to use C is because it's fast, like very fast, right? And we're trying to build kind of almost an embedded environment, but we're using Raspberry Pis. So if we use C, we can kind of easily move to embedded environment, which would be Arduino's downsizing what we do to the smallest possible footprint to kind of make it easier. It'll also reduce our costs down the line if we do that. Again, here's kind of the diagram. If you've taken 1310 or 1320, this will probably be very familiar, where you have preprocessor, the compiler, assembly code, assembler, object file, and then the linker, right? This is kind of how the compiler does this work, essentially. So again, since we do have a compiler, there is no funkiness with data types. Like water is water. It's all the same, whatever you declare it as, it should stay consistent. There is no, that's one of the things that JavaScript, a lot of people want to have a lot of testing for, is because you test all the edge cases in case it changes, because it's all at runtime. Runtime meaning when the program is running, it's decided what data type it is. Here, the data types, kind of a classification, right? The primary are kind of the most basic, right? Some of the things that you might not recognize is Booleans. C doesn't really have Booleans, but it does. So depending on compiler version they might have, you also have to include other libraries to have access to them. But functions themselves, they're kind of a data type, right? Everything in C can be considered a number. So functions, they just serve as a point of reference. They have a number assigned to them, kind of in the same way in assembly, right? If you say, I want to get to a function, right? You essentially in assembly, you say, go to wherever this function is, right? And it'll go to wherever it is linked in your complete code, if that makes sense. That's also why when you put your function definitions, when you make your functions, there's a certain order you want to put them in when you're running your C code, right? You want your definitions at the top, not at the bottom. you want to keep your functions at the top. If you have a main file, you want your functions at the top. Why? Because it needs to know those functions exist first before everything else, right? Then there's also putting it into other files, and that's later on. And then user defined. These are kind of like abstractions. They're not really covered in C. There's more of C++, so like classes. We do have structs in C, and they are used, but generally people that code in C, they like to stay away from object-oriented programming in general. Here's a little bit more about the data types. So you have char, int, float, double, long. These are all numbers. You could think of them as numbers. This is a number representation of a character, right? You put them together and you get a string. Now, whenever you make a string, you need to have enough space to have a null terminating bit at the end, right? So if you have to have however long your name is, right, you need to have an extra bit at the end to tell you to stop. This is the end of the string, essentially, right? Void, you can kind of consider null as kind of a void. Void is just a term to say that you shouldn't expect anything back. So you use that in the beginning of functions. That's mainly where it's used. The pointers, again, you're just storing a number, right? The number is just a representation of where something is, right? Functions, kind of the same thing. If that makes sense. Naming, there are specific naming schemes in C. There are other languages that might give you more space for naming, but generally you have to follow these 4 rules. First thing you want to make sure whatever you're naming is not a keyword, right? Anything that the compiler decides is a keyword could be break, like example break, char, constant, anything that you would use in code, you'd see in code, you don't want to use that, right? Then you want to make sure your name only has letters, digits, and underscores, right? You don't want to mess. The reason why you don't want to mess with them is because those things are stored on a different level representation. So there's UTC, I think it's UTC code, which is what is used to kind of, everybody knows, if you know what ASCII is, right? That is a digital representation with numbers of letters, right? If you include anything else, those don't exist in that ASCII definition, right? So it'll look at it and be like, don't know what this is. Essentially, the compiler will say, this is not within the ASCII representation. How can I use this if I don't have, it'll kind of treat it in a special way, almost as if it's ASCII, but not ASCII at the same time. You just don't mess with it, right? The first letter of a variable should be a letter or underscore. And there isn't a specific rule on how long your variable can be, but generally under 31 characters is good, right? Anything longer than that, you can start to hit these barriers that are within compilers, right? If you go in, I think 2312, right? You might go over why 2312 or 1106, they talk about why we have standard definitions for things, right? We'll use a different definition. Instead of writing int, we'll write int and then underscore how many bits it is, right? It's because of this discrepancy in compiler, right? What you're talking about between compilers might be different size. So you want to make sure that this stays the same. So it's the same thing with variables, a variable length. If you exit out of that length number, you might be messing with compilers and the way they run. And especially since C is OS specific, right? So if you make an executable for Windows, for Linux, for Mac, they're all separate and they should not be treated the same. So you can't just interswap them. They're very specific in that way. Scope. Scope is kind of another basic programming sense word. It's just about where a variable exists. Where does something exist and where is it inaccessible? So for example, I crossed out where the C programming stuff is. That doesn't pertain to us. But you can see the red area is like global variables, Should never be using global variables. There are some exceptions for global variables, but generally you should never. You'll actually, some professors will give you 0 for using a global variable. So you want to avoid that. There are some cases where you can kind of justify using a global variable. For example, if you need to store a value for something specific. Let's say you're making a game, right? And you need to know what the value for up, down, left, and right is, right? You can kind of use, you wouldn't define it like this. You define it as like a macro, essentially. But that's the way you could justify those. It's kind of like environmental variables. You don't really mess with them. You just know they're there, kind of thing. Okay. And then I guess let's get started with hello world, right? For a basic C program, you have 4 components, right? You have an include, which tells the compiler what library you're trying to use, essentially. Then you have your main function, right? This is what is being run. And you have a printf, the most basic way of sending something to the to print something out, right? And then you have semicolons. Everything in C has to have semicolons. Other languages like Python don't have to use semicolons. You can just start a new line. It'll be moved over, but you can't do that here. And then commenting. Commenting is an important skill, especially when we're trying to work on a big project like this. You need to be able to communicate, and you need to format your code in a way that other people can understand it, right? You want to make it as easy to read as possible so that anybody else can come in and work on it. It also goes into some of the other onboardings where they talk about documentation is very important, right? To know what's going on in the program is very important. So I guess, let me see if I have this done installing. Good, I'm working on that. I can show I have VM set up. Okay, so you want to start off with your include, right? One way, the best way to code, in my opinion, is to have documentation up whenever you're trying to look something up. So for C, I think there's tutorial point. Is generally some of the best documentation you can find. They do include a lot of what you want to cover. You can also use kind of just enter any kind of question you have. You can say, hello world in C, right? And it'll pull up anything. Programize is nice. I like the way they have their stuff formatted, right? So that's how you can find out if you can start you to know everything off the top of your head is kind of as you go. So here we can start with, we have our preprocessors telling us what functions we have access to, essentially, right? Oh, see. Oh, did I just crash? Okay. Great. Okay. Okay, so you can see the kind of basic structures. You have your preprocessor directives at the top, and then you have your main function, right? So in here, I'll place basic printf, right? And something to always check is that you have your semicolon in place. Can't imagine how many times I've had some coding done, right, and I can't find the mistake, and it's just the semicolon missing. Is sometimes the error that'll be spit at you is there's an error at the line below the colon, right? So be looking there, but sometimes you just look up. It kind of considers it kind of the same line because you haven't ended it at the beginning. So there's no end. So it's kind of the same line. So that's something to also consider. And then if you just save this, let me see. You open up terminal, and then you cd into wherever you have it. Then Linux already has pre-installed GCC, so you just GCC whatever the file is, and that'll produce for you this a.out here, right? To run a.out, it's the same on if you've installed the MinGW extension, right? // and then whatever the name of the file. So if you compile it with MGW, it'll give you an a.exe. So you just instead of this, you'll write a.exe. But I have an a.out here, right? And this will spit it out. Okay. On to further ahead. Oh, commenting. This is also one of those things where, hey, you can learn. I think one thing that you should take from here is that there is a shortcut for comments. It should be right. Add line comment or toggle line comment, toggle block comment, control /. So if you go here, say this is a simple program, right? And then you press control /, it'll automatically turn it into whatever you're trying to do. You can also move stuff around, alt, up, down, just kind of getting used to being able to use the shortcuts and just kind of slowly incorporating it in. Also, another important point is the command palette. So VS Code gives you a command palette that you can you can think of it the same way as Mac Spotlight Search, right? It gives you top of the screen. So if I put Control P or Control Shift P, yeah, Control Shift P, it'll pull up the palette. I think also Control P, yeah, Control P also works, right? So if you have other extensions that you're working with, for example, if you're doing stuff with source control, you can kind of get, I think it's get graph here, and you install this, right? Whenever you want to run anything for get graph, you will run it from the command. You want to run it from the command palette. So see an extension here. Oh, sorry, command palette. Control Shift P, and then you'll say like get graph, and then add repository directory. If you have, I don't have a Git file to test this with, but you can view Git log. It'll show you kind of how to command it. You can kind of really get deep into some of these extensions. One extension that was featured by VS Code is Dendron, which is essentially a note-taking extension for VS Code. So it allows you to do some really interesting things, kind of like refactoring your, kind of the same way our coders will refactor code. You can kind of refactor your notes. It'll give you this, but that's like a whole other thing, kind of like making databases-ish, managing how you want to manage the knowledge that you get, right? You can kind of, as you learn C stuff, you can make your own documentation for each kind of function that you're using, let's say, and prerequisites, and kind of absorb that into the way you learn. If that makes sense. Okay, and then operators. Operators are the most basic thing here. If one thing that I don't use that much would be, and it's kind of interesting to see because I think a lot of coding classes, they don't cover it, which would be this ternary oscillator, right? This is essentially an if statement, right? You give it something, you put question mark equal to give something, expression, and then you pass kind of the same. I can show you question mark, and you'll say like statement one, and then if that's sorry, I think it's statement, then question mark, and then you have something, so like value 1 and value 2. So essentially it's just saying that here's a statement, right? If this is true, then select the first one, right, which is value 1. If it's not true, select value 2, if that makes sense. That is that. Since I know a lot, you might cover it a little bit when you get into digital logic. Some of these other operators rarely ever used, like the bitwise operators, right? Anding stuff together. If 1 and 1 together and it together is still 1, right? But if either one of them is a 0, then it'll be a 0. These kind of operations. Then the assignment operations, kind of just basically almost the same. They're just equal to, but they're just building on to whatever the value is there, right? Okay. Are there any questions? I can stop that. Then you have your conditional statements. These are the most basic conditional statements here, right? So if condition, this is also kind of UML formatted way of looking at decision making, right? So the diamonds are decisions, rectangles are code. So kind of look at how you want to structure your way. If you want to structure your code in this way, you can also start from this point, then to your code. Or if you're trying to comprehend what you have, you can take your code and turn it into something like this, right? So you have your if condition, and then the pointy ends of the diamond are kind of your decision point. So true, false. So if condition true, do whatever's in here, right? Then there's also the else block, right? If this is true, and then it'll give you the else block. Then there's else if, which is not the same as if else. Okay, so else if is if the first if is not true, then do the else if, and if that is not true, then go on to the else statement, right? Then this switch expression, also rarely used. It kind of has a special place because of how unique it is. You kind of have to do a lot of extra work to implement it. The cases are not as simple to comprehend. You also have to have the value that you're passing in, right? In your switch expression, has to be a number. So you can't do everything that you'd want to do with it. But it is there for the special circumstances where this is the most efficient way to do it, right? This is the example of the code, right? So if statement. Another thing to also use is IntelliSense. Okay. IntelliSense. So whenever you're doing something, right, it should pop up this code snippet here. All you have to do is press tab, and it'll automatically fill it with you. So it's like if value 1 is equal to 1, then do printf value is equal to 1. Here. And then if you put int value 1 is equal to 1, that should be good. So if you just compile this again, also, the way compilers do spaces or next line or files, this is also going into how operating systems deal with files, is they have kind of the same as like a null terminator. This is the end of this line, go to the next point, go to the next line. For Linux, that'd be /n, and I can't remember offhand what it would be for windows, but they're not interchangeable in the same way. So adding /n should add a space here. Save this, recompile, and now it's formatted properly, or formatted the way you would expect it to be formatted. Okay. These are all the specifiers. Again, I don't think we expect you to memorize these. It's just that have these in the back of your head or have them offhand or ready whenever you're looking at code, because sometimes some of these more unused values might be used. For example, for if you're going into signature creation, you have to deal with these large numbers, right? In your C classes, you don't cover how do we deal with those large numbers? How do we do these calculations when we have a range? Let's say you need a massive prime number. How do you do those operations, right? The precision. Science has its own way of tackling those kind of questions. So whenever they need to run these huge computations on supercomputers, they're not using the same kind of int, decimal. They have their own system that they're using to represent numbers, if that makes sense. It's just like, for example, some people complain about precision for doubles, longs. You can only get so much precision. Some precision is lost. Certain cases, they get rounded up. It's just the way the math works behind the table, if that makes sense. So if you do take 2312, they do cover how they tackle this kind of problem. So exponents, they kind of have this big function. I mean, this big, I would describe it as kind of structure, right? And then each part of the structure represents something in a function, right? So if you have e to the power of, or whatever number to the power of this, plus this, minus, how do they represent negative numbers? That's also covered in 2312. I mean, I could go into it more, but that's something more for the next lecture. We talk about NFC, signatures, how do those work? How do we guarantee something is secure using math? There is no guarantee, but how do we almost guarantee it, right? And then here we have loops, right? So one thing to always make sure is you have an exit statement. So for loop is the most common loop, right? So you have your first part, which is your initializer, right? What you're keeping track of. You can kind of think of it as like a flag, just to keep track of your loops, right? Then you have a conditional statement. So, hey, is this statement true? Then do another for loop, right? Then I++ is just an operator. You can mess with this to get special kind of loops. So for 3318, where you go 3318, where you go into algorithms, you kind of end up messing with the way you iterate, right? You'll use I as a variable, but you'll iterate through a list in a specific way. What is the most efficient way to get to a certain number, right? If you have, if you're trying to do binary search, right? It's kind of the same way if you want to do like, what do you talk about? O notation. O notation is where it's kind of about half-ass something runs based on the number of variables you're putting in, right? So O of n is just linear, right? So let's say you give it a list of 10, the speed it'll run is whatever size 10, right? But if you give something that's O of n squared, right, it's going to run at the same time of, so if you give them 10, it's 100, right? That's something you get further down the line. We might do some kind of funky loop wrangling, or we might do it in another way. While loops are essentially the same thing, except that while checks first. So if the condition is not true first, then it won't do anything. But do while, it'll do whatever's in do, and then it'll check the while afterwards. So this is kind of useful for those one-time executions, kind of if you want to check for input from a user to say they're not giving you the right number. You're asking for a number, they give you a letter, right? You put a do while loop, it'll go through. But if they don't put, you have a check at the bottom, right? If the check returns, hey, this is not what I'm asking for, you can just do while again, right? Pointers. Pointers, kind of the most complicated thing to cover. So everything we know is a number, right? Pointers build on to that, to the maximum. It kind of, you're almost entering into kind of assembly talk, right? Because the number is generally just an address, right? Generally, the compiler is assembly or the machine code is the only one that works with the address. So now you're working with addresses, right? Getting around some of thinking about this and creating a way of processing it takes time. If you don't know what pointers are, the best way I would say to get used to using pointers is to you have to take a dive and start using them. If you don't, you'll always try to do some kind of funky passing. This is just the most efficient way to pass addresses. This is the way you want to pass addresses. The only problem is now you have to do memory management, right? Without pointers, you kind of don't have to deal with memory management in C, but once you do, you definitely have to do memory management. So I think that's also with functions, right? So you're maintaining data. Every time you create a function, you have to recognize, do I need to pass by reference or pass by value? This also goes into that idea of scope, right? If you're passing something in and it doesn't need to be changed at the original point, then you need to pass by reference. So for example, I can do here. Let's say I create a function and I'm calling it, and I want to return an int. Let's say, add a number, right? And let's say for this example, I don't want to pass it back like this. I want to pass it like this. Int A, int B, right? Then now you want to make a comment. So you're like, this adds B to A. A should be okay. So we'll use one of the assignment operators. So we'll use plus equals in this case. A plus equals B, right? Okay. And then let's say we have another value here. Also, this needs to be passed. So I'm telling you I'm going to pass a pointer here. And now I'm using the address of in this example. So I'm saying I'm creating pointers that have the address of whatever I want to pass. just. And if I just compile this, oops, I think it's the other way around. There you go. So now you can see that the value has changed. Now in this situation, if you're doing this on a large scale, this might not be the most efficient way. What I like to do, what a lot of people like to do is just, if you're trying to figure out what the value of something is at a point, you just add a printf and then put whatever it is. The most efficient way to debug, right, is to use a debugger. So for Linux, that'd be GDB, right? It's more of a terminal CLI interface. If you want to go super in depth, right, I would recommend getting Visual Studio, which is also made by Microsoft, but is more robust in what it can do. So if you want to just, in general, for this project, we want you guys to use VS Code, but in the future, if you do want to get into it, if the language you're working with is supported by Visual Studio, it's a full ID. So you get a lot of extra features. You'll get debugger, right? Another interesting thing that people don't cover is the performance. How do you measure performance, right? It gives you an ability to measure performance when you're running and testing and debugging. It'll tell you how much space you're using for your file, for your program at each point, wherever you put a breakpoint. It gives you all these extra features, but since we want to keep everybody together, and it does include JavaScript, but we want to keep VS Code here because in the future, to future-proof yourself, I recommend VS Code, right? Because it is open source, and you can kind of get any language into it. VS Code, if your language is not on this list of ones that are supported, or for example, if you go to different, I think they might add more in the future, but if you work on anything but what is included here, VS Code, Visual Studio won't work for what you're trying to do. It doesn't give you that opportunity to. There's ways to get around it, but it's just more of a hassle. VS Code makes it very easy to bring in extensions. Okay. Okay, and then if a lot of people kind of give this kind of data structure analysis for any data in general, right? So you have your address and then actual value beneath it, right? If your value gets too big, there might be some kind of funkiness that deals with addresses. You might run into this when you're doing assembly for Raspberry Pi, right? There's only so much space that you're allocated. You're only given, I think it's each line is 16 bits, right? So that's a limited amount of space you have. So if you want to do, yes.
What's the difference between Visual Studio and VS Code?
Visual Studio, right, is a full IDE. It gives you everything you would need, right? It gives you a debugger. It gives you kind of the extra features. You can also do unit testing in it. They have their own way of kind of pre-built. It's all there for you, right? You can get started. For example, if you want to install a compiler, right? They'll give you the compiler, right? Pre-install. You don't have to do any kind of funkiness with your environmental path in the same way you would if you're installing like MGW. VS Code is kind of a bare bones IDE, right? It only gives you, it's kind of like a text editor, but you have to build everything else yourself, right? Everything else you want, you have to put it yourself. So extensions, kind of your workflow. So that's why I recommend VS Code, because you can kind of pivot to any language without having to worry. But if you get used to Visual Studio, it's kind of hard to switch back, because if you're working in that language, right? Getting those nice debugger tools. I know GDB is very not beginner friendly, right? Debugger, since it has to be in the console, essentially. Visual Studio will give you a UI representation. It'll give you exactly this beautiful representation of it that is you don't get in the console, right? It's just one step above. But the problem is if your language doesn't fit within the languages they have, then you're kind of stuck. And you also have to deal with Microsoft's special way of dealing with stuff, right? So Microsoft tends to push a lot of their tech, right? Even for me, when I was trying to figure out if I wanted you guys to use Visual Studio Code or Visual Studio, it's tough because I think I have it here to run. So if you want to run printf, right, on Windows, you'll have to include extra header files to tell the compiler that Microsoft has, which is MSVC, I think, Microsoft Visual something C, I think C or C++, right? You have to tell it that it'll scream at you, give you errors, right, that you normally don't have to deal with if you're dealing with GCC, right? Printf just works, right? If you want to printf on Windows with their compiler, you have to say, don't run these special deprecation measures, right? They kind of see as like kind of pushing C forward, if that makes sense. They don't want you to do stuff that's kind of dangerous, that could be dangerous-ish, or they consider unsafe, but then that might be the case for everybody or whatever situation you're in. So that's one of the reasons why you also might not want to use Visual Studio. You kind of get lumped in and they'll make you kind of code the way they want you to code, if that makes sense. Is that any other questions? Okay. Creating functions, right? So we did cover creating functions, right? And in the case where you want to bring a function out of a file, so for example, if you're working on a big project, it's very easy just to have another file and move everything to that file, right? So to move everything to that file, you need a header file, and you need whatever C file that you have, right? You can not include a header file, but it's generally good practice to include a header file. It's just kind of, you can get away with it. Just please don't do that. So say I want to take this and I want to put it somewhere else. Folder. Are you kidding me? probably very important to save. I guess this is the perfect time to show you the formatting tool. You just right click, right, format. And then since I'm running C++, it'll reformat everything the way it should. So if this is like mine, you have kind of like this kind of squinched code. Also have to configure it. There you go. It formats it all in one way, right? So it adds the spaces where you should have spaces. You can also change it whichever way you'd like it to format. Now, if I save this, this should also, see, yeah. Sorry, include multiple definitions. Let's see here. Redefinition. Let's see.
Do you need to put if not defined, then defined?
Oh, yes. Uh, Do you remember we put in the header file?
Yeah. Do you need to put the information inside?
Which information? I can't. I'm having trouble remembering. It's not about the information that controlled.
No.
Normally, I just use one of my older files just to start from. There we go. There we go. And, okay, I think it's used.
And then you put end.
And diff at the end.
At the end.
Here?
All the way at the end, at line 6.
Oh, right. Should work. Multiple definitions. So saved. Yeah, I'll just avoid this till later. Okay. Malloc, Calloc, Realic, and Free. One of the most important things you could want to tackle, right? Essentially, this is your way of dynamically allocating stuff without having it pre-allocated kind of by the compiler, right? So when you're creating int values within normal functions, the compiler already knows that's going to happen, right? So it already kind of like pre-asks for this space, right? And it gets rid of it once it doesn't need it. If you don't do that, you have to do it yourself. So whenever you're doing multiple calls, there's ways to kind of make C do it for you, right? Where you'll have a function and you make a definition within that function, and then you kind of extract it out by taking the pointer to that and then closing the function, right? Or exiting the function, passing the pointer out. That's one way, but that's not how you want to do it. You want to do it with malloc, calloc, or reallocate. You use realloc to reallocate to increase space that you want. So you want more space for something. You have a larger array, you want to increase the size of your array. You realloc. Malloc and calloc are basically the same thing, except calloc sets everything to 0. So all the memory that is within it, zeroed out. There's no anomalies. Like when if you create an int and you don't set a value to it, and then you tell it to print it out, it'll give you whatever was there before, right? It's extra work if you go, this goes more over into 2312, right? It's extra work for the computer to zero stuff out, right? It has to manually do that. So you have an option to either do that or not. You probably want to zero it out, right? Or sometimes you don't want to. Generally, it's not that much of a difference, but it can be a difference depending on if you're working on micro Arduinos or microcontrollers, right? those things can add up, right? And there is, depending on how old the technology you're working with is, might have a shelf life for memory. Something people don't tend to think about is like, okay, I have SSD, this will last me forever. Technically, it won't last you forever. It only lasts you however many writes it's guaranteed for, right? There is nothing infinite in its usability, if that makes sense. Even kind of, there is a theory that if you set up a computer in a specific way, right? So the way computers are set up is you have kind of like gates, right? You have two things that come in together and then a decision pops out, right? Essentially. The problem with that is that every single time you do that, energy is lost, right? So there's this new concept, I forgot the name of it, what it was exactly. I don't see it coming down the horizon because of how complex it would be to implement, but essentially is you send that energy back through, right? So you're losing the energy when it goes through the decision-making process, right? The logic gate. But these special logic gates, they take the energy and they just kind of like pass it out, if that makes sense. And then the decision is pushed through, right? So that's something to think about here. We might be doing malloc or calloc. We might use it in a special way that it's not designed to. So, for example, taking random data that was there before and using that to generate our number for, let's say, random number generator. That's one way you could go around it. When it comes to encryption, though, or signatures, you do not generally want to do that because then your program becomes predictable, right? You can kind of predict what it's going to output based on what's on the computer or not. You want to make numbers as random as possible. Well, that's further down the line. Okay, segmentation faults, right? This is back to pointers. This is, if you see a lot of programmers, they might have segmentation fault on their shirt. It's something that's kind of the hallmark of using C, right? So that universally understood, I've messed up somewhere in my range. I'm using something that I shouldn't be using in your memory management. And memory management is just a hard thing in general. So segmentation faults do happen. The problem is it doesn't tell you where it happened. So it's your guess, which is also why you kind of want to modularize your code, right? So you can kind of pinpoint where the mistake is. You can kind of code in a way where everything's kind of together and it's kind of one piece, right? But generally that's not good to be able to test to see which point is your program failing, right? Segmentation faults only happen once the execution happens. So let's say you take input from a user, right? The code before that runs, if there's no segmentation fault, then it should be fine, right? But afterwards, and then if you have a segmentation fault, then you know your mistake is somewhere there, right? You're accessing something you shouldn't. There's also cases if you're dealing with allocating arrays, right? If you don't change the value, let's say you're using malloc and you're getting random values in there, right? The compiler will sometimes scream at you because you haven't assigned a value to some of the things that are in there, right? It's saying, hey, hold on. You're using something with malloc, and what you're using could be something that was in the past, whatever was being stored in the memory, right? So it will scream at you, be like, okay, this is not good practice. So what you would do in that case, you kind of switch over calloc, and you need to assign those because you can't, for certain situations where you know the maximum size, right? You can malloc it, but if you're taking decisions from something inside that memory and you don't zero it out, then it becomes a problem. If you're writing to it, if you write to it first, then you should be fine. The compiler can also scream at you in that case. Files. So files just have one major component, which is the stream, right? Stream, if you go into C, C++, they deal with streams in a different way. So kind of where we deal with like fprintf and whatnot. We in C, if you take they might remove it from the curriculum, from what I've heard. If you took 1325, but this is C out is the same as like a standard out, right? And then you'll put this out through there, if that makes sense. They deal with streams in a whole other way than how we deal with it. But this is how you create your streams, right? Then you have to open everything that you're using, and you have to close everything you're using. There should be a F close here, but whenever you open something, you should close it. There's also kind of something to take into consideration would be buffer overflow, right? It's where you put expect something, since C is so low level, right? You give it more than what it's expecting, and it'll put that memory in to something, it'll kind of spill out, right? So let's say you have a string of length 10, right? And a string of length 10 as well, right? And this is your password. Just saying this is hypothetical, right? And you define them right after each other, right? And then you have a call where you take scanf and you take 20 characters. And you're using these two variables. One is like, you might have not assigned it as constant, but there's ways to get around constants, right? So you'll assign the first value is whatever they're entering, right? And the second one is whatever the password you're checking against. So then if you go down and you check compare, if they put in first 10 characters are the same as the 10, last 10, it'll basically slide over in memory, right, to where the password is. So they'll be able to compare it and it will run just fine. That's something you have to take into consideration, and data desanitation is very important when working in C, since you don't have memory safety. It's just you're working at the lowest level, right? And then now it's your turn. So I have two kind of ideas you can kind of work on. Ideally, I'd like you guys to post it on GitHub, right? So you use some of the skills that you learned from the past lectures to make a Git repository on GitHub, and then kind of make a project. So you have, first would be a banking system, right? I'm not asking for you to go as complex as, you don't have to use file, input, output. You can make it as simple or as advanced as you want. It's just that I'd like to see you guys use some of everything that you know up to this point to create kind of like how you would imagine, how would you go around making a very simple banking system. It doesn't have to be very secure, right? And then, or you could decide to make a quest line based text game. So quest line based text games are kind of the origin of the internet games, right? They give you kind of this story based text, and then you have decisions you make. So you can use your for loops, do whiles to make those decisions to say, it doesn't have to be very dynamically, you don't have to make it dynamically. You can just make it like a pre-made storyline, but I'd like to see that. And then if you do, if you have your own idea you want to do, you can do that as well. And I guess that's all. Later on today, I'll post some of the resources that I recommend to use. Are there any questions? If that'll be all, essentially. You can just send me your GitHub link whenever you're done with that.
Should we send it in the server or?
Yeah, put it in the server. Put it in Project Share, actually. You can kind of think of the server as kind of like your communal space. You can put wherever you want. Project Share is kind of just, we want to create a community that's active, and one of the easiest way to kind of get invested in a project is that you see other people are excited into your project. They also have interest. So that is something to think about down the line, to kind of, we're here. If you have any questions, ask them in the general chat, because if you have a question, probably everybody else has the exact same question. So we kind of create want to create this collaborative environment where you can have people to work with. Kind of, oh, we have this interesting project idea. Okay, we can do this, but that's further down the line. If that's all, I have this room until 2. So, any questions? Till 2? Oh, sorry, it's till 3. Sorry, till 3. So if you have any questions, I can answer that.
How much could you want the bank, or what do you mean by banking system? I guess like deposit, withdrawal, or
Everything you could do at an ATM.
okay, cool.
I would define that as the baseline.
Okay. How's, I guess, like a timeline of when you would want it, the project by? Like a couple of days.
Within before the start of, say, before Long gets back. So that's
Okay, cool.
should be like to the 20th, 21st ish, somewhere around there. That should be fine.
So the onboarding will be only something.
Say again?
21st is the date like when we start our tickets.
Oh, you'll have extra tickets, but you'll have tickets by then. We'll give you some kind of beginner tickets to kind of get some of the people working, especially I know since a lot of you might not have any experience in JavaScript. That's kind of might be one of our focuses to kind of get you guys, since I know C is taught in your classes, so you might be more familiar with it. So we don't want to just shove you into a ticket and you're like, oh, I can't do anything that is here, right? It doesn't make any sense. I don't even know where to start on this. We're going to give you some starter ones. We'll have also some starter C ones, just to get you going and understanding some of the methodology, and also we'll give you some coder feedback from that.
Thank
All right.
you.
Have a good day.
You too.
So I thought I installed GCC properly, but it's still saying it's not recognized.
Oh, did you finish everything?
I thought I did. I did.
So close out the PowerShell and everything. Close it all out. And then open it back up. And then try running GCC dash version. Dash version. Okay. You complete all the stuff, like go back to the, okay, so that's like the first half is instructions. The second half is you actually have to tell the computer where your compiler is at.
It's not that bad, but
You do kind of environment.
Does that make sense? The assembly
So if
language.
you go back to the, and you scroll down a bit. So right, add, you have to add a div, right?
Yeah, it's
So
C
you
and
can just type it in, search, edit, environment.
it's C and assembly language.
No, edit environment. Yes. Right. And then, actually, let me see.
These are the properties. This is the property.
So choose the path variable in your user variable and select edit. So go back to the same screen. And then edit. No. New. Go back. Yeah, here. Okay. Yeah. And then click new. And then now, when you installed the compiler, did you send it the same, did you put it whatever it gave you to put, what it was? The compiler where, for installation, when you put it.
I'm not sure.
So when you ran the compiler, did you
Yeah.
change anything? Did you say put the compiler somewhere else?
I don't think so.
Okay, then it should be fine. So go back to. I mean, no, you need that open.
Oh.
Sorry, edit.
I don't know like how to like
Wait,
get
copy.
Oh, sure.
Wait, cancel. Edit. New. And then now go back to the document and paste this line in. That is where your compiler is.
Okay.
Then okay. Okay. Then now close all the PowerShell, everything that's PowerShell related. Now open it up. After GCC. Try G++.
Did I like download it?
Try closing it again. And then open it. Check if there any other PowerShell windows open.
No. I don't have anything else open.
Okay. Try again. Did you install the toolset?
I did I think I did all this.
Did you run this?
I mean, yeah, it's up to date.
I actually opened command. Let me see if it's open. Run GCC dash version. No. Did you run the pack dash SYU twice?
Yeah. But I'm not sure if I did it on like the right ones. Cause like you do the first one here. And then when you do the second one.
Do it the same. Search M main GW. Yeah, run that.
Yeah, I think I did it here as well.
Okay, now run the tool set. Also. Okay, now go back to the scroll down. Is there more? Okay, try all PowerShell again. We go back to the edit environmental variables. Maybe we can save. And then select the path. Yeah, it's not saved.
Oh, it's not?
So put new. Then you put that address. It was in the other one.
Oh.
I mean, the Visual Studio. Press, yeah. Press enter. Wait, press enter first. Then okay. Then okay again. No, no, close. Okay.
Oh, no.
Okay, so now GCC dash version. Dash version. Okay, should be good.
Okay.
Now, whenever you can, now if you want to test some VS Code, you can also do that as well. So, I think control, if you press Control Shift T, that won't things from that. I know Control Shift, just give me a point.
Oh, okay.
No, it's a dot exe.
A dot.
So it's dot slash a dot exe. Yes.
Oh, okay. Yeah, thanks.
Okay.
All right, thanks so much.
No problem.
I just like what like the C stuff we were doing in this project. What will we doing in C?
Exactly.
Yeah, like what is it?
It's a broad question.
Like which concepts we will be using? We will be using like strength pointers.
Oh, structs? Yes, we will be using these.
And like what will we be making like each component?
Okay, so we're making, you can see we're making the kiosk and the server, right?
Okay.
You can kind of think of them as one thing at the beginning, and later on we'll split them into two parts. But think of it as just one program that runs on the Raspberry Pi, right? This program does several things, right? It reads from the NFC card reader, right?
Okay. So reads what it
So you have to be able to interface with the reader, right? So that's what you do. We have a library we'll use for that.
oh
So we'll have to move it a little bit because figure out what
Yeah.
we want, right? So we'll be doing that. We'll also be taking whatever we get from there, right? Putting it into functions, whatever number we get, and doing signatures, right? So that's where instructions might come in, right? Where you have there are certain values in the past when you're doing signature. It's kind of like the base that you use, right? So that's what you use as the structs, right? But those might be preset depending on how we're trying to do it. Other than that, we are having a little bit of file input because we have our master private key is not going to be stored on the file. It's going to be stored on another USB kind of. It'll be stored outside, so you have to take it in.
file input output.
File input output. And also some logic that's inside. So further down the line, when we try to grandfather in old keys, let's say we lost it, right? We need to grandfather all those old keychains.
Grandfather. Yeah.
Grandfather is in like we bring it into our new system,
Okay.
right? So you have this old key that we know is verified, right? Because the public key is open, everybody can see it, right? Do you know what public key private key is?
Very vaguely, like just like it's a
So-
unique thing.
It's a unique number, right? And then there's another unique number is the public and private key. They're both unique numbers. They're kind of mathematically linked together, right?
Like there's a function, there's an algorithm you can do.
I wouldn't describe it as a function because
Algorithm.
it's kind of like an algorithm is what I would describe it, right? So you use your public key. Everybody knows the public key, right? And you have a private key. What you do is you take kind of like a hash of the message, right? Which is, you know what a hash is?
No.
A hash is where you take like, if you have a text file,
Yeah.
right? And you turn it into something else.
Okay, so like
So you extrapolate this data in a certain way,
you
right?
turn the text into something else. You turn the data, you turn the data.
You essentially have a function, right? It takes text and it'll spit out your number.
Oh,
That makes sense,
okay.
right?
Yeah.
And
So
depending on the
cryptography.
text, yeah.
Cryptography.
Right? It's an extrapolated rule, right? So you'll take the hash and use the public and use the private key to sign it, right? Then since the public and the private key are linked, you can use the public key to take that signed hash that you use on the private key
unmove whatever private key is done, right? And then compare that to what you use, what you get from the hash function, right? If it's the same, that means the document hasn't been changed. Does that make sense?
So we'll be doing this in C. This diagram probably do this.
Yes. And I don't know how far in depth we will go into it. It will be because we're still working on. I still need to touch on more of the architecture
Yeah.
side, if that makes sense. But that's generally what we're doing.
Okay, so this file output and what is the first? The
Interfacing with the
interfacing with
the
the
reader.
NFC. Okay, yeah. Thank you.
Okay. All right. Have a good day.